Quick question. Do your end users always, and I mean always, without exception, work on company-owned devices and IT-approved apps? I didn't think so. So how do you keep your company's data safe when it's sitting on all those unmanaged apps and devices? 1Password has an answer to this question: Extended Access Management. 1Password Extended Access Management helps you secure every sign-in for every app on every device because it solves the problems traditional IAM and MDM can't touch. Check it out at onepassword.com/XAM. That's onepassword.com/XAM.
Packet pushers.
Welcome to Day 2 DevOps, where the dev oops is in the details. I'm Kylie Middleton, and on Day 2 DevOps, we explore those details and how you can learn from the mistakes of others and build a solid DevOps practice on Day 1 and beyond. With me on this journey of learning and doing is my co-host, Ned Bellavance. Hi, Ned.
Hey, Kyler. Today on the show, we are talking to some folks from Cloudflare, and we're going to cover topics like turtles on turtles of hierarchical log processing. We're going to talk about sanding down the rough edges of OpenTel with the Prometheus team and the social upside of upgrading to a new platform in a language that more people know. That's an interesting and novel idea.
Absolutely. Helping all of your team get empowered sounds pretty important. Leading us through those tremendously large stakes are Colin, Douch, and Jayson, Sena, both of Cloudflare. Jayson is an SRE, reliability engineer at Cloudflare, and Colin is the observability tech lead. Colin and Jayson recently wrote an article entitled Adopting OpenTelemetry for Our Logging Pipeline about how they successfully migrated Cloudflare's tremendously broad logging infrastructure, which handles millions of logs per second from all over the world across something like 236 sites, from SysLog-NG to OpenTelemetry. The scope of Cloudflare is amazing, and making changes to something as fundamental as logging to keeping the lights on is mind-boggling. So today's talk was fantastic. Without further ado, Colin and Jayson. Thank you, Colin and Jayson, for joining us from Cloudflare. This is so exciting. I read your article about replacing SysLog-NG with the observability stack, and I can't even imagine the number of computers and the breadth of Cloudflare. That is such a critical, essential thing. But let's talk about first, like, what is Cloudflare? Because I think the average person has never heard of Cloudflare, and the average person doesn't know that Cloudflare like runs a significant portion of the internet. So either of you, I would love to hear, what does Cloudflare do?
At its heart, we're a massive distributed network, right? We run a couple of tens of thousands of machines in 320 cities, I think, these days. So it's pretty big. Both Jayson and I started off on the SRE team before we sort of specialized. And most of our role there was making sure the whole thing stayed up. So the fact that no one's heard of us hopefully implies we did a good job.
You're not in the news like CrowdStrike. Sorry, CrowdStrike, calling you out today.
We have been in the past.
That's true. And hug ops to all the SREs that have made the news, because that's never a good day for you. And my heart goes out to all of you. I've been on call. I know what's up.
So yeah, I've also worked in SRE team, mainly on Edge. So basically the one that handles the proxy traffic. So yeah, we've encountered like a lot of attacks that we wake up everyone because it's affecting customers. And we've seen a lot of issues in the internet.
I think that's why network engineers generally know Cloudflare, because they're the ones that make the news of like, oh, there's been a DDoS that's broken all records. It's 10 times as big as the last one. And Cloudflare absorbed it and everything stayed up, which is just incredible. With any knowledge of networking, you're just like, how is that even possible? And you all make it possible. That's very cool.
The very early days, Cloudflare made a big bet on a technology called Anycast. And a lot of people in the very early days said it'll never work. You can't do TCP Anycast because the way it works is that it's up to your ISP which route you take to Cloudflare. And people were worried that if it's up to the ISP, well, they can just send traffic randomly anywhere, right? So your one packet may end up in one data center, it may end up in another, and that doesn't really work. But turns out things are a lot more stable than people had worried about. And so Cloudflare sort of works. And that's how we can sort of absorb a lot of those DDoS attacks, is that unlike traditional sort of DNS-based load balancing, an attacker can't decide where they want to send their traffic, right? It's up to the ISP of whatever device they've hacked.
That's interesting. Actionalizing the internet into little nodes. That's very cool.
I've heard the term Anycast before, but I don't think I entirely understand what's involved with, I want to go talk to this public IP address. How does my traffic actually get there? Is that kind of what Anycast is handling?
The concept of Anycast is that we announce the same IP addresses from every single data center we have, which means that an ISP will end up with 300, 400 different routes to the same IP address, one to each of the data centers, right? And it's free to choose whichever route it wants. And generally in networking, that's the cheapest or whatever, right?
Mm-hmm. And you don't just have like 3 or 4 data centers, Jayson, right? Like you're working on the edge team. About how many locations are we talking about here?
We span like 320 cities and 120 countries. So yeah, we have like 280 terabytes of network capacity. So yeah, that's how we scale and how we were able to handle attack traffic.
I see. So yeah, you're spreading this potential DDoS attack across this wide range of different locations. And while that would overwhelm any single location, when you take it in aggregate, I mean, you're not just shrugging it off, but you can handle the worst that the DDoS services can deal out, at least so far.
So initially, the architecture of our edge is using Anycast, right? So it's harder to control which sites or POPs receive traffic, but we've developed like Unimog. You can also see that on our Cloudflare blog, where we can steer traffic to different colos, to larger colos to handle those attacks. So we still have the benefits of Anycast where the attacker can only target one IP address, but from that one IP address, we can steer the traffic to multiple sites.
Okay, so let those edge sites sort of pass the traffic along to these larger colos and then have them make the determination, nope, this is garbage, drop it.
Yes. Let's say there's a smaller countries that's a smaller colo, a less number of servers. If it cannot handle the traffic, then that's the time we decide, okay, this traffic is attractive traffic, then we forward them to a larger colos.
And I imagine detecting that requires a lot of monitoring. Hey, we got there.
I'm a network nerd and I would love to just talk about the network architecture the whole time, but you all are specialists in the logging, and that is what you ripped and replaced at, I can only imagine tens of thousands of nodes. So can you walk us through, like, let's just start with the basics because I'm certainly a novice here. What is SysLog-NG and what is the new shininess that you deployed, OpenTelemetry? What do they do?
So SysLog-NG was a program that started in 1998, which makes me feel very old because that is older than some of our junior engineers. It was started as a fork of the original BSD syslog daemon and sort of ported over to Linux and all the rest of it. Because it's so old, it's C-based, and particularly in the world of like Log4j, having C components in our logging pipeline really made people quite nervous. What we've switched to OpenTelemetry, in particular the OpenTelemetry collector, is a bit more modern. It's written in Go, which makes it memory safe for the most part. It's also a lot easier to manage. And I think that's one of the key reasons why we switched, is that C is not a core competency of our team. Like, I've made a few upstream contributions. The SysLog-NG guys are really nice and really help you through it. They sent me a t-shirt. But like, we've got 8, 9 people on our team now, and I think one of maybe 2 or 3 that have written professional C, which makes it hard for other people to contribute.
And the reason you would contribute back to SysLog-NG is, are you bumping your shins on things that people at maybe a smaller scale or scope wouldn't necessarily encounter?
Yeah, things like the ability to rate limit logs based on various fields and things like that. We have hundreds of different services running on our machines, and we want to make sure that no one service is able to disproportionately produce logs and kill the whole stack.
Maybe I can pose this question to Jayson. What do you see Cloudflare gaining by doing this upgrade? Is this something that everyone should do? Should we all just go rip out and replace SysLog-NG with OpenTelemetry?
Well, we have this mantra, right? That if it works, then just live it, right? But both has different advantages. Like in SysLog-NG, it's written in C, so it's fast. Now with OpenTelemetry, there's a little bit of overhead. And like in the scale of Cloudflare, we want to make sure that if we migrate to OpenTelemetry, there will be less resource usage. Because like what I mentioned earlier, we have sites that has like smaller number of servers. And if we put too much overhead on logging, then it will be less feasible to migrate to OpenTelemetry. So yeah, if you don't have any constraints, then I guess you can test OpenTelemetry. But if you have like large scale, then you need to measure first if it can handle the performance, and you need some tuning on OpenTelemetry as well.
I like the mantra there. If it works, don't touch it. I don't do that in my personal or professional life. I just think that's good advice for probably myself also. Yeah, my phone barely works. Tell us all about it.
If you're an engineer, right, you want to experiment things, because if you want to learn new things, you just don't think about it. You need to test it. You need to experience it, right? That's why we engineers, we love to test different things. I read about this. I want to test these new things. And that's the time that you experience, okay, this thing works. Maybe we can work it out on our production. It just starts with experimenting with your personal projects, right?
Always experimenting. And my experience is always, I can read the docs, I can read wherever the marketing materials are or whatever's on the GitHub repository. But until I actually try to deploy it and use it, that's when I realize, oh, there's this bit that doesn't work the way I would expect, or it's unintuitive the way this particular feature is implemented. Not that it's necessarily anything wrong with the application, but it doesn't work the way I expect it to work.
Yeah, and also that's the good thing about Cloudflare, right? You have the scale, you have like a big environment to test how this thing works, how is the performance compared to like SysLog-NG, and if there's like some tuning.
That's totally my experience with scale. A lot of things work on small scale, but if there's a little bit of friction and then you multiply it by 100 and then you multiply it by 1,000 and then, suddenly that small amount of friction is a huge time suck and it's 3 full-time engineers maintaining the thing. So I can imagine if you can customize the Go one to work exactly right and not have memory unsafe languages, that's pretty powerful at scale. I'm curious about logging. So logging for what? Logging for firewalls? Containers, servers? What did you replace the logging on? And where does OpenTelemetry live? What does it do?
We collect logs for virtually everything. We don't run traditional sort of firewall boxes or anything like that, but we have our own firewall daemons built into all of our things. The core concept of Cloudflare or edge architecture is that everything runs everything. And so every server runs, we call it the Nginxes that are not really Nginx anymore. They run, as Jayson said, Unimog to sort of route traffic and things like that. But we also have network devices that we capture traffic on. We have a whole bunch of containers running in Kubernetes. OpenTelemetry now handles it all.
I'm sensing a theme here. Nginx that isn't Nginx, SysLog-NG that's no longer SysLog-NG. Is that just a trend that like as you scale, you stop being able to use off-the-shelf tools and you start to need to customize and build in-house?
I think one of the key takeaways is that Cloudflare does not do anything particularly special. We just do a lot of it. Our logging pipeline in particular, like no one of our boxes does more than a few thousand logs per second, but taken in aggregate, when you have tens of thousands of boxes, that starts to get quite big, right?
Yeah. And I imagine shuttling all that information around can become pretty difficult. So are you aggregating your logs outside of these individual boxes on something local at each edge site? Or are you like shipping those logs back to a colo or something? What does that architecture look like?
Yeah, so basically we have we call them core data centers where we collect centralized logs. And we also have hundreds of sites where that's the leaf nodes where we run OpenTelemetry, collecting logs on firewalls, errors on Nginxes, databases. So we forward them to a central location like Europe and US. And the collector, the receiver on that data centers, they run on Kubernetes, which process the logs, put it to Kafka, and then pre-processing them again, checking fields. If the logs needs to get dropped because they log in too much for a specific service, then we write them to Elasticsearch.
Okay, so you have a whole pipeline going there of how it's ingested, transformed a little bit, and then placed into other systems for additional analysis and extracting information and useful stuff, I guess.
Yes. We also have a dead letter queue when one, let's say, US is unreachable for specific sites. Because as we mentioned earlier, we have different sites on different countries, and not all of them has reliable internet. We have site that has gets disconnected every day, and internet is not reliable. Sometimes when one site can connect to Europe data center, but it cannot connect to the US data center. That's why we have this dead letter queue where it can send from the Europe data center, and then it can sync back to the US data center.
Mm.
So, and also the other way around, so that we have like reliability on sending logs.
Interesting. So I'm curious, like, how do you prioritize the logging traffic versus the other traffic you're trying to serve? Because I mean, Cloudflare's reason to exist is to help deliver content to endpoints and to clients and also provide that level of protection. You need the logs to do your analysis and check out the health of your systems, but you need the systems to deliver that content too. So do you prioritize one type of traffic over the other?
I think that's kind of an interesting point because every bit of CPU that we spend collecting telemetry is CPU that we can't spend serving customer traffic, right? And at the end of the day, customer traffic is what pays our bills. And so we do a lot of like resource hierarchy stuff on the edge using C groups and things like that. So everything is very well constrained, and we have very specific budgets for our monitoring stuff versus our customer stuff versus our everything else. And we rely heavily on Linux and C groups to help manage that and make sure nothing is using more than its fair share.
In my day job, I have written pipelines just personally that run a couple hundred times a day, and I'm so proud of those. And as long as I'm not thinking too hard about the scale of the stuff that you all have written and how many times a second it runs, it's bizarrely scaled. That's so cool. How do you begin to deploy your changes at this scale? I imagine there's some sort of like dev environment and promotions. And is this like Jenkins that's no longer Jenkins because you've modified it so much because there's tens of thousands of nodes to deploy to? Whatever you can share, I'm curious about.
We want to deploy our changes, OpenTelemetry changes live, because we cannot just disable a server or a site because we want to deploy OpenTelemetry. We've encountered like a few problems where OpenTelemetry can disrupt traffic, but we were able to fix that. But it has impacted traffic because there are like applications that synchronously logs to SysLog-NG before, and that was missed during the deployment. So when we deployed OpenTelemetry, it has affected the logging. That's why I mentioned earlier that in Cloudflare, we also look into the performance, because if the logging pipeline is slowing down the customer traffic, then that will be a problem.
Mm-hmm.
Yeah, so that's one of the few things that we've encountered. So at the same time, switching from SysLog-NG to OpenTelemetry, because we use configuration management. So sometimes the switching is not like really fast because, you have like different states of different applications, like configuration states. So that's why we need to put them together, like stop SysLog-NG and then start OpenTelemetry right away. So that's also another problem that we've encountered, because before we thought that, okay, we have the states written in salt stacks, so it can just switch over from SysLog-NG to OpenTelemetry right away. But when we tried it on production, that's not the case. There were like a few seconds of gaps, and that has affected the services that uses the logging pipeline.
Interesting. So you're using Salt Stack to deploy your configuration to the endpoints. I'm trying to repeat this back so I understand it. And so you had an action that would disable syslog, and then another action that would apply the OpenTelemetry configuration, but that wasn't happening quickly enough. So there was a gap in there. Is that what you were encountering?
Yes, that's right.
Is that a stop the project kind of problem? Like there's a 2-second gap when we switch over our logging. Is that critically important? We need to fix it? Or is that this is something that's just going to happen? We'll deal with it.
It's critically important because we cannot stop a site because we want to deploy OpenTelemetry, and it's disruptive to customer traffic. So to be able for us to deploy OpenTelemetry without disrupting traffic, so we need to make the switch over really fast. At the same time, we need to make the application to be asynchronously logging to the logging pipeline, so that if there's like a millisecond of disruption, there'll be no like blocking on the application itself.
Those of us old enough to remember the BSD syslog protocol, it's very explicitly over UDP because having any sort of synchronous logging really screws you. The specific problem we encountered was our Nginx instances, as we mentioned, were blocking trying to write to a Unix socket to write into our logging pipeline. And if that chews up the worker threads trying to write those sort of Nginx access logs and things like that, then that becomes a real problem because those threads aren't serving customer traffic. And so if we're down for even 2 or 3 seconds, like that's real impact.
Yeah.
It makes me laugh thinking that switching out the logging protocol caused so many logs that it crashed the workers trying to work that. I don't know. It's just a circular dependency that made me laugh.
So what was your resolution to that issue? Did you have to rewrite portions of OpenTelemetry to ease the switchover, or was it rewriting your salt stack configs to do things in a different order?
Yeah, it was rewriting Salt. So we ended up basically creating a systemd one-shot unit that turns off SysLog-NG and then starts the OpenTelemetry collector.
Okay, so rather than doing it as two separate steps, it's all kind of happening in one step.
Yeah.
What did you get the gap down to? Is it milliseconds or is there like no gap? We have nothing.
There was still a gap, but it's in the order of sort of 100 milliseconds maybe, which isn't, perfect, but it's small enough that TCP retries and things will make it not as much of a problem.
Interesting, you brought up TCP. So is that another big difference that OTel uses TCP and Syslog used UDP?
So the SysLog protocol is originally UDP. We did ship things over MTLS, so over TCP to go over the internet, but all the sort of local traffic between or inside the data center, that was all UDP or over Unix domain sockets.
So log formatting is super important, especially if you're trying to keep historical records. Did you need to alter the way the logs were formatted to use OpenTelemetry, or did the log formatting stay exactly the same and it was just switching sort of the way in which logs were collected and then forwarded along?
Let's pause for a message from today's sponsor, 1Password. Imagine your company's security is like the quad of a college campus. There are nice brick paths between the buildings. Those are the company-owned devices, IT-approved apps, and managed employee identities. And then there are the paths people actually use, the shortcuts worn through the grass to the actual straightest line from point A to B. Those are the unmanaged devices, shadow IT apps, and non-employee identities like contractors. And most security tools only work on those happy brick paths, but lots of security problems take place on the shortcuts. 1Password Extended Access Management is the first security solution that brings all these unmanaged devices, apps, and identities under your control. It ensures that every user credential is strong and protected, every device is known and healthy, and every app is visible. 1Password Extended Access Management solves the problems traditional IAM and MDM can't. It's security for the way we work today, and it's now generally available to companies with Okta and Microsoft Entra, and in beta for Google Workspace customers. Check it out at onepassword.com/XAM. That's onepassword.com/XAM. And now back to the podcast.
One of the big annoying things is that OpenTelemetry bases itself on OTLP, the OpenTelemetry line protocol, which is protobuf based. Our old format just shipped JSON across the internet, and it turns out protobuf is very heavy on CPU, which meant that we ended up actually foregoing that line protocol in order to just keep doing JSON, because it turns out Go's JSON.marshal is way faster.
Oh, that's interesting. Like, I'm not a Go developer by any stretch of the imagination, but I encountered protobufs a few years ago, and I was like, what is this strange black magic here? Seems like it would require a lot of work on the back end to make it actually do what it's supposed to do. And it sounds like that is the case. The CPU spikes up when there's protobuf involved.
Yeah, the annoying thing is that protobuf does have a JSON encoder. Like, you can encode protobuf messages in JSON, but even that is like 10 times the CPU of just marshalling JSON yourself.
I recently wrote something in Go that uses the JSON marshalling, and it is very fast. I mean, I'm not running it anything close to scale, but the fact that it takes zero time to do that marshalling and unmarshalling between different files and whatnot, it was very useful in my very tiny use case.
The other thing there's a logging library called ZeroLog, which has a really interesting scheme to be able to produce JSON messages without doing any sort of heap allocations, which we can sort of steal a lot of inspiration from, and we did in order to make our JSON even faster.
Not being a professional developer, you might have to tell me a little more about this heap allocation thing.
When you allocate memory, you have to ask the kernel for some block of memory, right? And doing that call to the kernel and back again takes some amount of CPU. And if you're doing it thousands of times a second, it takes a lot of amount of CPU. One of our machines, we benchmarked it. This was one receiving those log messages. It's a 96 core machine. It was spending 70 of those cores just doing memory allocations.
Wow. Okay. That is exactly the sort of thing, like when you're running in just a tiny shop, that's not going to matter to you at all. You have plenty of CPU, but when you're running at scale, suddenly that's a huge problem. Did you have to rewrite portions of OpenTel to reduce the heap allocation?
Yeah, we ended up using a lot of Golang has a concept of a pool where you can allocate memory once and then store it in a pool that other people can, or other services can then use it.
Okay.
So instead of having to allocate sort of thousands of things per second, we can allocate one set of thousands of things and then just reuse those allocations.
Carrying all the groceries in at the same time. I get it.
Yeah.
No, that makes a ton of sense. And because Go is, memory safe, it sounds like that's a safe thing to do. You'd have to be very careful with that in a C world to not allocate the wrong memory or grab the wrong memory range. I hope I'm using all this terminology correctly.
Ned and I just pretend to be developers. We're doing our best to pretend to understand everything that you're saying. So you're adopting a new foundational tool and protocol across Cloudflare, which is, as we've talked about, just a huge company. How do you prepare the humans for this change? Is there training? Is there new tools to get installed? How do you prep your team to run it?
Yeah, we produced as many sort of metrics and things as we can to keep things up to parity. The other good thing about the OpenTelemetry collector is that it's enabling us to produce many, many more metrics than we used to. Particularly SysLog-NG, the Prometheus integration for it is a bit lax, and it's very hard to get more metrics out of it because, again, you have to write C. Whereas with the OpenTelemetry collector, we're able to build our own custom components and export whatever metrics we want, which makes the debugging experience so much easier.
Yeah, when you mentioned Kubernetes and running stuff in there, my mind immediately went to Prometheus. And I mean, correct me if I'm wrong, but my understanding is that Prometheus talks OTel pretty well. Like they're in the same pool playing nicely together.
The Prometheus OTel receiver is still in the works. There's a lot of annoying things about that OpenTelemetry protocol that make integration a bit more difficult. Things like OTel allows a broader range of characters in metric names and things like that than Prometheus does. There has to be sort of translation layer that makes things a bit more annoying.
Would have thought the rough edges would have been sanded off a little more by now, but I guess you're doing the sanding. You're out there.
By the time it gets to us, you will have sanded off those edges. So thank you both for all that work.
The Prometheus guys are doing great work doing that sort of integration and working through those problems.
Jayson, was this a phased rollout where you did it one edge site at a time or one location at a time, or was the rollout distributed in a different way? I'm curious what the logistics were for that.
Yeah, so we actually have, we call it canary colors. So we started first like canary colors that serve internal traffic. So Cloudflare enables sites, but only handles the internal teams so that if anything breaks, it won't affect customer traffic. It will only affect people in Cloudflare. Then from there, we check the performance, like if OpenTelemetry able to handle this amount of logs, then from there we move to your tier 3 colors where they serve like small amount of traffic. And if we see that, okay, it will be able to handle this amount of logs, then that's the time we move to like larger sites. Then we slowly rolling it out like multiple hours, like 4 hours or more, so that we can slowly check the progress while we do the deployment. At the same time, if something goes wrong, then it won't affect a lot of customers. Like what I've mentioned earlier, that one deployment affected Nginx that proxies customer traffic. So we were able to catch that earlier on. And if we deploy the OpenTelemetry right away on all the sites, then it's going to affect a lot of customer traffic, and that would be a problem.
Right. Did you have a rollback plan in place for if things just went sideways on you while you were upgrading one of these, like, what'd you call them, tier 3 locations?
Yes. So we actually have like a deployment system in Cloudflare where something goes wrong, we can apply a salt state right away together with the deployment. Because in salt stack, you have this called high state where it applies all the states, like all the configuration changes on the system. Now, if something goes wrong, we're only going to apply the changes on OpenTelemetry. So that will be shorter and we can deploy this right away on the affected machines. So that makes the revert faster.
By the end of the project, that process was very well tested.
I can imagine.
Any rollout that I've ever done at any scale, that you have to test the rollback and see how effective it is. And sometimes it's very effective and sometimes it's not. And it's easier to just forge forward and take the pain. But at your scale, that's not an option.
Was there a human intervention part of the rollback that you're looking at metrics and you're pulling the lever, or is it more of an automated decision that the tooling does?
Yeah, it was definitely humans pulling the lever at the end of the day, but we were monitoring the roll out pretty well. We did miss a few things, and our SRE team rightly called us out for it, and we rolled back and we tested more things. The big problem we had, I think, is that no one has really touched our logging pipeline for 3 or 4 years at least. Like it's just sort of been chugging along without breaking. And so we uncovered all sorts of weird cruft and hacks and things like that that we didn't realize existed, and we then had to re-implement or fix.
Oh, interesting. Like you didn't know this popsicle stick was holding up like half of the edifice and like, don't move that.
And sometimes you'll be surprised. Oh, this machine is receiving logs. I didn't know that before because it haven't been touched for like almost a decade. So you'll be surprised, like specific things running, and you only notice it when you need to change something.
Totally. Like the synchronous logging. I can imagine that called you out. You switch it out and then the service stops working. And you're like, oh.
One of the annoying ones was we run a system called Monit that is able to run sort of remediations if it notices something wrong. And SysLog-NG and later OTel both had a weird pathological behavior where they would just sort of get stuck if one of the destinations that they were trying to send to went away. Like they would keep trying to send logs to it and your TCP memory would spike up and it wouldn't try and reconnect. So we had a Monit script that sat there, looked at the number of TCP connections and then killed syslog-ng and restarted it if things sort of started going badly. OTel had that same behavior, but we didn't have that Monit script in place to sort of fix it, right? And we ended up doing it better because we're able to more finely tune our OpenTelemetry collector written in Go. And now we don't need that Monit script. But that sort of thing where you have to learn that, oh, that's a problem that we need to solve.
It sounds like you've heavily modified the original OpenTelemetry software that you brought on board. Have some of those changes made their way upstream to the OpenTelemetry project?
Yeah, we're pretty heavy contributors to the OpenTelemetry project, adding things that we need, making things a bit faster.
Awesome. I just wanted to give you a chance to toot your own horn. That's excellent.
The OpenTelemetry project offers a system called the OpenTelemetry Collector Builder, or OCB, which allows you to integrate your own components and things really easily. So we do have a lot of like business internal logic, but anything that isn't Cloudflare specific, we're upstreaming.
That's wonderful. Thank you. Ned and I both release as much as we can for free. I think that's huge for new learners and, well, really anyone smaller than Cloudflare, which is all of us.
Really grateful to Cloudflare that they let us do that sort of stuff, right? Like so many other big companies are very open source averse, and Cloudflare is very open to us contributing to all sorts of things.
I couldn't help but notice that both of your titles mention observability, but neither of them mention monitoring or logging. Is that because observability is like the cool new buzzword, or is there a distinct difference between logging and monitoring and observability?
Well, monitoring is all about collecting data, right? You have your metrics, you have your logs, and you put them somewhere. Observability is all about how you can use that data to answer things that you haven't thought about. Like if I know that my service is going to maybe run up on CPU and that's going to be bad, I can add a CPU metric and track that number. But if I have a customer complaint, I don't know what metrics I'm going to need to answer that, right? Because I don't know what the problem is. And so observability is all about having the data available to solve those sort of unknown unknowns. And that's what our team is all about, is not just collecting that data, but making it available to our teams in a way that makes it easier for them to solve those problems.
That's fantastic. So for all the admins that are listening at home that run a network smaller than Cloudflare, which again is all of them, is there anything you all learned from doing this project that is applicable to them that they can take home and use in their enterprise?
One of the big reasons for us switching was that sort of social side of things where we wanted more people in our team to be able to contribute. I think so many people focus on the technical upside of things that they really don't focus on that sort of social side. And I think that really should be taken into account in your sort of decision making.
That's gold. right there. The fact that you've made this more accessible to more people to contribute in your group means you get a better application at the end. Because if somebody has a good idea and they can implement it, wow, you just empowered them to do that, as opposed to, well, now you got to go learn C if you want to make a change.
Yeah.
Jayson, is there anything that you took from the projects that enterprise admins at home could use?
I guess just to repeat what Colin said, C is not a core competency in observability teams, but at least everyone from observability team writes Go codes. And it's also good that everyone writes Go code, they can contribute. And if there's a lot of people knows OpenTelemetry runs in Go code, so they can give more ideas. Not only the two of us, me and Colin, can have an idea on how to improve OpenTelemetry, it also gives the platform for everyone, not even observability team. We also have like other teams pushing PRs to contribute to our like internal OpenTelemetry code.
I love that. Getting more of the enterprise empowered to help push everything forward. That's a good note for folks at home.
I think the other thing from a technical side is that, especially where, as we've learned it, the internet is not reliable. At Cloudflare scale especially, but especially for sort of smaller teams, when you want to ship something over the internet, it's entirely possible that destinations can go away, there's packet loss, there's whatever. And building redundancy into those systems and having multiple points of aggregation and queuing and things like that, that's desperately needed.
Absolutely. Redundancy for stability. That's super cool. Okay, so let's wrap this up. This has been so fun. If folks want to hear more from you, Colin, let's have you go first. Where can folks find you on the big bad internet?
I'm on Twitter at Sinking Point. I'm also on Blue Sky, colindou.ch.
And you, Jayson, where can we find you?
I'm not really active on social media, so I only have like a GitHub, Jayson Sena, and LinkedIn.
LinkedIn counts. I'm active on there.
Yeah. It's the social media we've all adopted after Twitter did, well, what it did.
All right. Thank you, Colin and Jayson, for appearing on Day 2 DevOps, and virtual high fives to you, dear listener, for tuning in too. If you have suggestions for future shows, we would love to hear them. Hit either of us up on LinkedIn or send some feedback via packetpushers.net/follow-up. And if you've got a way cool cloud project that you want to share with our audience of IT professionals, become a Day 2 DevOps sponsor. You'll reach several thousand listeners, all of whom have problems to solve. Maybe your product fixes their problem, but they'll never know unless we tell them about your amazing solution. So find out more at packetpushers.net/sponsorship. Until next time, just remember that doing DevOps is awesome, and so are you.